Okay, good afternoon, everyone. Today we start a new topic, is natural language processing. So, just as a summary, so you have learned some machine learning algorithm, and you already worked, like let's say some of them, SVM, neural network, logistic regression. So all of those algorithms need numerical inputs, but textual documents are not in numerical format. So the biggest component of natural language processing is learning how to convert those textual documents to some numerical equivalents. So as long as you have numerical equivalents, you can use those machine learning algorithms and basically getting using some similar approaches for processing them. So having said that, text analytics or natural language processing in general have three major components. The first one, information retrieval. Like if you remember in the last class, I talked about getting some information from Twitter API, or some cases you have some text document or web scraping. I'm not sure how you are familiar with that. So basically one step, which is still challenging, getting information. Then second step that we focus today and next class, today we mostly go over concepts, is information extraction. Just basically means how to convert those text documents to something numeric that is interpretable. And the last step is data mining or web mining in general. So here what you see from web mining, just mostly they talk about web scraping. So I think you can merge web mining with information retrieval together. So textual document is under umbrella of unstructured document. So when people talk about unstructured document, it just means data is not in row and columns. Or as an older format, they are not in RDDs. So I didn't cover RDDs because it's getting obsolete. But again, it just means you cannot fit any specific structure on your data entry. So can you tell me another type of unstructured data on top of text document? Huh? Yeah, images, videos, even robocalls. So they are just some machine learning algorithms that convert your voice to something interpretable for algorithms, so they can guess what you're talking about, and the robot answers you. So fortunately or unfortunately, 85 to 90% of all corporate data are unstructured. So why I'm saying unfortunately, it just means it's harder to process, but fortunately means there's some opportunity for you guys. If you be expecting text mining unstructured document, these are something new that is not that much common for the older generation to be able to process. So the size is getting double almost every 18 months. Just means you need a big data infrastructure to process it, just getting larger and larger. So somebody had a question? Oh, okay. So it just shows the importance of being able to process unstructured data. The answer for all of them is learning how to do text mining, or in general, again, I'm emphasizing a lot. It just at first much looks very scary, but it's nothing just being able to basically reformatting your data in the numerical form. So from today and maybe next few classes, we go over some basics of text mining, and I do actual text mining project. By the way, two things. Today I have a minor health issue. I should visit my doctor, so maybe class will be sooner. I don't have afternoon classes, afternoon office hours, but you can find me tomorrow. Also for the Spark streaming, it seems I using two different computers. In one of them was okay for my updated Windows and Hadoop. I think I'm not sure if you guys had the issue. It seems the Windows users has some issue in Spark streaming when you want to generate streams on your system. Have you faced that any issue?
I got like errors about stream listener, which is a package from Spark, and it said like stream listener is like they update that, so you need to change to stream without like instead of the stream listener while like installing the package.
Okay, so after you install the package, could you be able to run it?
No, like some connection issue, I guess.
Yeah, okay. Yeah, I think it's the other. If you use Linux, it doesn't bring any problem. I think for Windows users, some issues, but I found some equivalent. I upload that video later. But I think, but what about the Twitter? Could you get the tweets?
Like first time I can, but like after then I cannot like connect.
But at least for one time you could. Okay. Okay. So for Twitter you don't face any issue, but when you want to make a stream by yourself, probably you might face some issues, especially if you have a newer version of Hadoop, Spark, and Windows. Okay, so let's talk about similarities and dissimilarity of data mining versus text mining. So in both of them, you're looking for some patterns, either like maybe some clustering. So you might do some finding similarity of your observations. Sometimes you do prediction, so you find some connection between your inputs and output. These are same. So you do exactly the same in text mining. So some of good example is like CDC read tweets, and based on tweets, they can guess some parts of the country might be some flu outbreak. But I think it's not that much relevant during COVID because everybody has masks and like people are more cautious. But before COVID, they look at the like a stream of tweets, and if they read like people tweets, somebody say, "Oh, I have headache, I have nausea, I'm coughing," so they can guess there's some part of country might have some problems by just reading people tweets. Another one, if you look at the Google Scholar, there's so many people read tweets or social media, and they predict which part of the country vote for which U.S. candidate. So on top of that, which may not relevant right now, but the more relevant examples is like targeted advertisement. Like if you, let's say, if you, I think some of them are not exactly text mining, but maybe Twitter, Facebook look at your posts, your connections, what you're talking about, and maybe they guess your concern maybe is about skin products, or your concern might be about buying some laptop. So they read what's in your mind, and also they look at your cookies. So they put two information together and they guess what products is more fitted for your needs, and they basically do targeted advertisement. But in targeted advertisement, also they read your cookies a lot. So it's not just text mining. So the only difference is just structure of the data. So In structured data, that is, I think you have already have several classes. You have databases, you have tables. For unstructured data, Word documents, PDF, text, XML file, tweets, those are on the unstructured data. Okay, so let's look at 2 examples that I provided. Open the first link here, textprocessing.com demo sentiment. These slides are not available for you. Let me see. Okay, this is another course. This is your course. So you don't see week 12 NLP? Oh, you don't see week 12? Okay, let me hide and unhide. Show. Do you see week 12? Oh yeah, it's my bad. I just saw it. Yeah, that's I fixed it. Thanks for reminding me. So NLP basics. So I guess you can see now. Okay, I give you. Sorry, it was my bad. I updated another folder, so I give you like a couple of minutes to be able to download the Jupyter notebook, the PowerPoint, and reach to the page that I'm looking.
What's the difference between NLP and text mining?
Not big differences. These are, I mean, in some references they differentiate a little bit, but there's not biblical differentiation. So sometimes they're used interchangeably.
Oh.
But what I can say, in my point of view, natural language processing could be anything that any expression of thought in a certain language. It could be voice, and it could be text.
Isn't natural language processing part of Python package?
Yes, even a part of PySpark. So yeah, I think if you ask me, I would say text mining should be under umbrella of natural language processing. But if you look at different papers and people, usually they don't differentiate that much. So if you open the first link, it might ask you to click on advanced and then you reach it. So just type any kind of document you want. So basically, by the way, later I talk about the dictionary of NLP, but when they talk document, it could be one sentence to like one story. So Here it's a great movie, but let me change it. Huh? Click on advanced. Okay, let me do it again, hopefully. So let me do it. So since the first time I said yes to advanced, it doesn't show it here. But so just type any like sentence that is very positive. I love word booster. So analyze positive. So it said 80% positive, 2% could be neutral. So it seems very, very positive. So there's a subjective and polarity is also the polarity is very toward positive sentiment. Or maybe you can change to wearing. So let me make it challenging. Wearing mask is difficult, but is very good for being safe. So let's see what happens. So I have both positive ends. Yeah, it's kind of so-so. So because it has some positive and negative Word documents. So did you put same words? And it's very much is difficult, but it's very good. Being said, and it said different.
I mean, it's a polarity.
So you got differently.
Yeah, I got like, but like everything there is like.
Yeah, it's actually so it might be the programming program, but you should get exactly the same thing. So try the next one. So it has some visualization. So let me just copy and paste this sentence here from here. Copy, but you can make a new one for sure. Analyze. So in this website, based on the certain algorithm, the think is mostly positive. So 56% positive. And you learn how to do it, no worries. So I think if you had my visual analytics class, I already talked about this, some examples. But for who never had this class with me, so basically there's two ways of sentiment analysis. One is a traditional way of dictionaries. So some application, they have a dictionary of positive and negative words, and they count how many positive and how many negative words you have. And if the summation is more than 0, they think it's a positive sentiment. If it's less than 0, negative sentiment. But this is a very basic one, and it doesn't need even any machine learning knowledge. You just assign positive and negative words to a document. So more the fancier one that you should do is using machine learning. Basically, each word could act as a variable, and similar to any machine learning prediction. So you use those variables into an algorithm and do prediction. So you predict if a document is positive or negative. Any question about these types of sentiment analysis, either dictionaries or predictions? Okay, let me show you on the board. I'm not sure your friends could see, but let's say very massive, difficult, but very good for being seen. Very mass, difficult. But for so you should say some words that you drop, like D, E's. I tell it later on, but like a sub words, you want to get rid of them. So some of them may not be that much meaningful, like is, but, is, for, in. Oh, my favorite. In could be, not sure, but let's say just try. So you basically you have a very large table. Maybe the first one could be Apple. No, you. What is the first word in dictionary after A? Not characters. Yeah, let's say in English. Let's say the first one is Apple, but I'm pretty sure we should have something different. Yeah, so it comes anything up to here, even after say. So let's assume this dictionary is a table. For this document or sentence, I'm telling document because it's a technical term, but we know that I'm talking about a sentence. So it doesn't have Apple, so it's 0. It's maybe very 1, 1, 1, 1, 1, and the remaining are 0. So when you train a model, this could be an input, and you put this input in your model, and it predicts is it a positive or negative. But later on, you would see we go to the roots, or we do tokenization. So instead of wearing, maybe we just put wear. But I tell you about it later. But basically, each word or each token has your like larger data set. When you put in that large data set, for some words you don't have any existence, you get 0. For this, you have 1, and you just do your prediction. So these are some applications or benefits of text mining. So academic search in finance. So let's talk about the yesterday. Have you ever heard about what Elon Musk said yesterday? So he wants to sell 10% of Tesla's share. So let's see what happened today. So Elon Musk selling 10%. So yeah, I think it happened 13 hours ago. Elon Musk over Twitter, he said he wants to sell 10% of stock. So let's look at the Yahoo Finance. Let's look at the Tesla stock. So So yeah, I mean, I think in the morning it was more than, it was about 5%. It just bounced back a little bit. But 2.8% in Tesla's magnitude is a lot of money. So just one tweet. So you might, and it happened overnight. So 13 hours ago, it's like,
I mean, he tweeted about Dogecoin and like it got up like 200.
yeah.
Like, this thing, obviously,
It seems the last night he said something. So it happened on Sunday. So you can do different ways of doing. Some way you might hire somebody 24/7. They read every news, what happened every part of the world. What if? But it didn't happen this time. But what if there is a explosion in like a lithium mine in like Africa? It would affect. So what can you do? You either hire so many people that read all of the news everywhere, or use machine learning algorithms, text mining. So you have some API like CNN, Twitter API, or other APIs. You read text documents related to some hashtags. So let's say you focus on Tesla or some hashtags you're looking for, and your algorithm might predict this text or some information are so negative against some specific stock. So actually, I made a robot to sell or buy stock and crypto for me. So let's say, and no worries, these robots are easy. If you know Python, you can make a trader robot. So what happens? So your input is text. You do text mining. Let's say, and it happens overnight. So your input is like, let's say TSLA, which is Tesla, would go down, which happened 5% this morning. So it's just send a like command to your robot, and it will sell for you before you lose money. And maybe later, if you some information telling you it's just going up, it will buy ahead of time. So it's more complex than this, but and it doesn't just look at the textual document; it also look at maybe some other information could come from, let's say, GDP or whatever, same volumes, or like oil price. We don't know. We just integrate so many data from different sources. Definitely one source comes from text mining. Use those information, do the prediction, and your model would predict what happens in the next 2 hours, next 10 hours. So if you know what happens in the next 10 hours, maybe you can do some trading ahead of time. So again, for auto trading, you shouldn't just look at text mining, but definitely text has some rich information that helps you. I think for Tesla, the remaining doesn't matter. The most important was like the Elon Musk tweets. Yeah, what is your question?
So you made this robot, yourself, or?
Yeah, I have one for myself.
Is it like good? Like, have you seen like any profits from it? Like, you know, if this works or not? Because like I've seen some videos.
So yeah, my robot is good, but my model is not that much good. Yeah, if you look at those videos, usually they make very basic things.
Yeah.
But just keep in mind, I mean, for this auto train, you need a lot of information. Sometimes they just focus on RSI. This is a good indicator, but it's still just one among so many. So those videos is a good learning experiences, but I think from those videos, you can mostly learn how to make a good trader robot. But for these ones, you need to have some good amount of time, because like selling or buying, it just needs like 10 lines of code. So it's not difficult, but you need to have a good model.
And also, is it illegal to like do text line, let's say on like Twitter or Facebook, all that?
Yeah.
It's legal, so like you can use that model.
Yeah, I mean, for Twitter, they give you some free data, but it's not inclusive. But if you pay Twitter, you can get as much of data. There is a reason why people pay Twitter. You know, why they buy tweets. So one reason could do trading. Oh.
Just like this, like he wasn't doing it. Maybe he was coming in.
This is actually a good experiment. If you do auto trading, you learn a lot because you work with the actual money, but don't expect too much. But those videos, what I learned, they're just the modeling part of those videos is very weak. But still, I mean, it's very good to at least learn how to make a robot trader. That's very good. The auto trader. So you have control on your model. So you know, but the trader just gets a signal. So it just gets signal of the buy or sell. So this one is not. I mean, yeah, it's black box, but it's nothing just selling buy sell. So, for example, if you have Robinhood, you also have some buttons. So buy sell. So it's something like that. Yeah, exactly. So actually, I spent like 2 months, and still my model is not that much great. I think I need a lot of work. So this was like you just assume takes at least a few months. And you need to do a lot of testing because you don't want to be bankrupt. So you work with the actual money. So you need to have a really good model. So there was other applications that actually happened, I think, 2 years ago. Is like security and safety. So I think there was a terrorist group in Germany. They just used Yahoo as making some plan. So I mean, German intelligence, they had some text mining software. They read people's emails. Suddenly, there's something wrong. So the model predicted that there's something wrong with those communications, and they called the agents and then look at the emails in person, and they found there's like terrorist communications. And spam filtering, I think you have faced every day. So there's a junk folder. Sometimes they don't work good. So a few times, not a few times, actually more than a few times, but it happens sometimes when you send me email, it goes to my spam folder for some reason. I don't know why. So what I'm seeing, those models are not perfect. They have good accuracy, but some they made mistakes. For robot trading, so one big thing happened for me. So let's say for if the value is less than 1,000, so let me just tell you an example. So if let's say for the value is less than 1,000, you are 99.999 accurate. But what if you make one mistake for the value of more than 20,000? So let's say in these cases, your accuracy is just 5%. So means for high values, you might make a lot of mistakes and you might get bankrupt. So it's very challenging. You should test in several ways. Any questions so far? Yeah, Zoom. Let me give them 1 minute, so in case they have questions. So I'm telling you, there is some people that teach you how to do trading. So and there's a good guy, I forgot his name, but he's a kind of sincere guy. He's like in training 10 years, and he makes some live videos for his trades. I look at him for 2 days. Every day, he's a super expert guy. He lost like 5,000, 7,000. So even those people lose money. And the good thing about that guy, he's kind of very transparent. He just shares, like, today I lost $7,000. Some days he make a good money, but still there's a chance of losing money. I search for it. So he does day trading, but he's like been in this market for a long time. Still, some days he lose money. Let me Google his name on my phone. Let me see his name. Yeah, unfortunately, I cannot. Okay, I got his name. Okay, his channel is Warrior Trading.
Yeah, I've seen it.
Warrior Trading, yeah, that guy. I forgot. Ross, I think his name was Ross something. Ross Camera, yeah.
Usually streams in the morning, but
And I have one of my friends actually was his student, and I remember he told me first month he lost 120K. Yeah, one of his students, which is my friend, lost 120K for stock trading. So just keep in mind, these are something serious. So what I'm saying, I could make a very bad model and be bankrupt in like 1 week. So I mean, it needs a lot of work. Okay, so that's it for now. Okay, let's review some terms. These are there's no math behind of them. These are some dictionaries that some words that later on, when I say, you should understand what I'm talking about. So let me just read one by one. Natural language processing, NLP, a collection of techniques utilized to extract meaning from textual data. But if you ask me what is text mining has exactly the same definition. So again, there's not a universal definition. Document, a collection of words using format as raw or observation of a tabular data set. So document might be a little challenging for you to understand, but it just means every text unit that you want to process. So if the text unit could be a tweet, could be just one sentence, or could be like a paragraph. So when we have for text mining, so one column is your document. Again, it could be Twitter, could be not Twitter, tweets, I mean. Paragraph. So you have some variables. I said for each word it could be 1, 0, 1, 1. So it's just talking about that. So each row is a document. Later on, when we go to actual example, it makes more sense. But just keep in mind, document with the text unit. body data set of documents. So whole of this table is a body. Dictionary, the set of all words that exist in the body. Topic, set of words that co-occur. So some words might happen together, especially when we talk about n-grams, it makes more sense. Latent, the hidden feature that can't be measured directly but are essential to the data or not original features of the data set. So for example, it could like some documents could have like positive sentiment, negative sentiment, but it's just what you can get from certain document. Or some document could talk about finance, some could have a topic of health. So just basically what's the general topic that comes from our document. So these are the applications: information extraction, topic tracking, summarization, categorization, clustering, concept making, and question answering. So we cover some of them in this semester. So these are some terminologies that you might face later on. So unstructured or semi-structured data, corpus means collection of your bodies, terms, concepts, stemming, stop words, synonym, and tokenization. Okay. So, but what are the steps? The first step is just establishing a corpus, just means using some technologies to gather your information. It could be from email, web page. What I mean web page, mostly web scraping, digitizing, standardization, and basically getting your data in one location. So you guys, have you ever tried web scraping before? Do you know what does it mean? So some of your friends last year, they got some jobs that they start doing web scraping. Unfortunately, we don't have time, but it's a really easy one. Basically, you run some code that read a web page and extract information. So there's a beautiful soup one is one of the easiest one, but there's some other packages that you can learn. The second step, create term by document matrix. So it's exactly what I told you. So it's like you have a large matrix. Each row has your document and you have columns that telling you if you have some certain words in your document or not. So basically, in the second step, we should make our matrix. But some words are not that much meaningful in terms, they just like a stop words. And for something like varying, maybe you need to do a stem. Otherwise, varying words. So these could be considered different things, but in terms of meaning, they are actually the same. So for words, for verbs, we do stemming. We just go to the sum of the words. And also we take care of synonyms. We know that some words might have exactly the same meaning. One thing, for some certain words, they might have more impactful meaning. So let's say you're reading some let's say you're reading people's emails in CDC. So let's say you work in the CDC as a text analyzer and you read their documents. You don't read in person. You have a algorithm that read it. Maybe for privacy, you shouldn't read. But what I mean reading, I means a standardized reading, not by human. So let's say you run some algorithm over the documents, and do you expect to see COVID-19 a lot in this time or COVID? So you expect to see such work a lot. So it may not drag that much of attention. But what if you read their, let's say, emails and you see fire or bomb? Probably this drag more attention. So as you see, if I make a matrix, for each of them, I give the value of 0, 1. But we have seen some words might have they have more words to take more attention. We should take more attention, give more attention, because like COVID is a very common word. Almost maybe in CDC, every day you have too many like documents about COVID, but firebomb is like something that doesn't happen that much. So having said that, there's some techniques like TF-IDF. We give some values to some certain words. So when you make this matrix, maybe let's say value of COVID maybe 0.1, fire maybe 3, bomb maybe 5. So
the numbers there are be like 5, 3, so like they have like fire on the matrix, so like not as 1 or 0, but
yeah,
5 or 3 or 0.1.
Exactly. So, or maybe in let's say make a better example, more peaceful example. Let's say about you run your text document over, you do text mining over tweets, and let's say you're focusing on the financial tweets. Let's say some tweets is about stock, or you see the word of stock, you might see the word of NASDAQ. So for financial text, seeing stock and NASDAQ may not drag that much of attention. But what if you see Elon? Although may not be that fundamentally relevant, but it's still Elon, the stock market drag a lot of attention. So in this case, maybe when you do those algorithms, text mining, to predict what happens next day, maybe for if you see word of Elon, maybe its importance is like 10. So basically with TF-IDF, you give some importance to some certain words. Okay. So any question from you guys or still over Zoom? If we wait 1 minute for them. Actually, these are not the only methodologies of text mining. I'm just giving you some examples for the famous ones. But I'm pretty sure if you look at some tutorials or papers, you have seen on top of TF-IDF, there's several other algorithms, but it's just one of many. But what is TF-IDF? So TF stands for term frequency. So it just means number of times term T appears in the document divided by total number of terms in the document. So I sell Tesla shares. So what is the time frequency of Tesla here? 1 divided by 5. 4, sorry, 1, 2, 3, 4, 1 divided by 4. So usually time frequency for short documents like tweets is just 1 divided by R. Usually it's not more than that. So what is IDF is logarithm or logarithm of total number of documents divided by number of documents with term T in it. We just want to see how common is that certain word or term in our body of text. Okay, let's look at this example. Consider a document containing 100 words, wherein the word COVID-19 appears 3 times. The term frequency is like 3 times COVID divided by whole document, 3 divided by 100.03. Okay, assume we have 10 million documents, and the word COVID-19 appears in 1,000 of the documents. So logarithm of 10 million divided by 1,000, so IDF is 4. TF-IDF weight of COVID-19 is 0.03 times 12 times 4 is equal 0.12. So instead of putting 0 or 1, we put 0.12. So look what happens if we have more documents about COVID-19. Maybe in CDC, half of your documents is about COVID-19. So here, instead of 1 million, we have 5 million. Half of the documents is about COVID-19. So the IDF weight here is 0.3. What it was 4 when just in 1,000 of 10 million, you have about COVID-19. Now you have 5 million. So IDF is 0.3. So TF-IDF is 0.009 for CDC versus in the regular text is 0.12. Any questions why suddenly TF-IDF dropped? So just as a summary, in the second situation, word of COVID-19 is a very common word. It doesn't direct that much of attention. So it seems in every document people talking about COVID-19. So on at least half of the documents, 5 million people talking about COVID-19, but it was in the previous example. In the previous example, it was just 1,000. Basically, TF-IDF cancels out very common words. It just take out their importance. This is another example. So we have 2 documents. One of them, this is a sample. Second one, this is another example. In the first one, frequency of example, 0. We don't have example. Term frequency of example in the second document is, in that document is actually you have frequency of example. So frequency of example is 3. And it's not the whole document, we just put a summary here. So it's not, this is another example. It's just like a basically a summary of the table. So maybe it was like 3 or 4 sentences. So here we just summarize it. So example happened 3 times. So term frequency is 0.429. The TF-IDF for first one should be 0 because 0 times everything is 0. But IDF for example, so we have 2 documents. One of them has example. So 2 divided by 1.3. TF-IDF of example, the first one is 0, the second one is 0.13. And as I said, this is one of the basic weighting algorithm. There's some other algorithm that give different weights, but it just TF-IDF is just one of them. Okay, so after you process your text, you make such a matrix. Could be this is the basics one, so you give 0 or 1 to each text document, but it might have different weights if you do different pre-processing. The next step, basically summarizing the table. So in that table, you might have too many zeros, or some terms doesn't happen that much, maybe 1 million, or like they are not frequent. And you might remember when you have too many variables, you might be stuck in local minimum. So you may not get the optimum result. Maybe your accuracy, your model won't train very well, and your accuracy would be very low. So what happens here, we might get rid of some of the terms, or there is some other algorithm. You might do feature selection, actually. So feature selection also helps you to reduce your matrix. On top of feature selection, there's some other algorithms. So basically, you summarize some vectors into just one vector. But again, this course is not a text mining course, so I don't go to in depth. So just let's assume if you have for your project or assignment, you just get rid of columns with too many zeros. The last one, using machine learning algorithm, you might do classification, you might put topic modeling, clustering, trend analysis. So basically, in the last step, you have just a numerical table. You apply a machine learning algorithm to do your own prediction. Yeah, actually, next class. If you have some interest, please read this. Basically, I teach in next class. But if you are, go to, where did I put engrams?
Okay.
Yeah, here I talk about engram, but I teach in the next class. So basically, you try to find co-occurrence of some documents together. So we want to see which terms work together. That's just a very basic definition. These are next Jupyter Notebook. We make our own text documents, but we have some basically some text mining experiences like Twitter, those kind of things. But here we just type by ourselves. Okay, where was the, okay. There is some, for topic modeling, also we have one of the algorithms, latent Dirichlet allocation, or LDA. Basically, it just as a very basic summary. Again, I don't expect you to go under hood, but under hood, you just assign random topic to each document, and then try to find probability of each document related to a certain topic, and they calculate the probability. And again, they sort out based on the assigned probability, and just goes through a loop, just assign until it converges to some certain probabilities that cannot improve further. So again, I know it's like a very ambiguous definition, but we might use LDA later to find documents topic. The underhood of this allocation is based on probabilities, so conditional probability of some document related to certain topics. So any questions? Yeah, today I should leave a little late, soon because of the several meetings, also my doctor visit. But if you are curious to do some hands-on experience, which I do in next class for sure, you can come here, like read about tokenization, engrams, how to remove a subword. So basically in the next hands-on experiences, we learn how to prepare our data. So first step was data gathering from like email, social media, those kind of things. Second step is basically how to prepare your data, which you learn in the next class. And in class after that, we apply machine learning algorithm. Having said that, I already posted a notebook, but no worries. Next class, I go in the details of them, explain one by one. And but basically, just if you look at the topics, first I do tokenization. Just means I divide one sentence or document to certain words. After tokenization, I get rid of some subwords. I do engrams, which just means I want to see which terms goes together. Then I do TF-IDF. I assign certain weight to some words and basically make a vector by using LDA. Okay, that's for today. Thank you very much. Again, tomorrow, early morning, I will be here. If you need me, instead of today office hours, you can find me tomorrow morning. Yes. Yes, we do. Yeah, come back. Yeah, it's like 7 p.m. Yeah, I come back. Thank you very much. Take care.